Let's look at the nomenclature of aromatic compounds now. It's slightly different than other nomenclatures. But first, I want to talk just a little bit about the 4 allotropes of carbon. Carbon is a very interesting compound. Not only is the whole organic chemistry based on it, but by itself also it's quite different. And this is a little bit just for your general knowledge, not so much as in that you will be asked this in aromaticity or anything. But there are 4 types of carbons possible, 4 allotropes, which means they have a different molecular structure. It's the same element, but a different molecular structure. The first one is amorphous, and amorphous just means that you have small particles, okay, of carbon in here, and it really has no shape or form or anything like that. And this is like charcoal or coal, something like that. That would be called amorphous carbon. The other kind of carbon, which many people are familiar with, is diamond, and diamond is one of the hardest elements out there. And it is a tetrahedral carbon, so its structure is based on a tetrahedral carbon, which is then sp3. If it's sp3, it's got all sigma bonds in there, and it's a very, very hard substance, okay, and that's diamond. The next one comes the most soft element, okay, and that is graphite, and this is still carbon, but this is a different allotrope. And this, the softest element or the softest allotrope of carbon, this is also based on carbon, but now this is more like benzene rings that are fused together, so it's kind of layered. Whereas diamond was tetrahedral, this is actually more like sp2, and so if it's sp2 and it's layered, it's a planar structure. And if it's planar, that means that things are just kind of smooth against each other, and that's why you can write with graphite. And graphite is a good conductor of electricity, and it's actually being used a lot to create electrical wires and all that. So it's a very good conductor of electricity, very different than diamond. Diamond, one of the hardest, graphite, one of the softest, okay, compounds out there, not compounds, elements. And the last one that was discovered about 25 years ago is the Buckminster fullerene. Buckminster fullerene, the short form is known as fullerene for it. And this is, of course, in honor of Buckminster Fuller, who made the geodesic domes. And it has a soccer ball kind of a structure. And the structure is based on carbons, which are about 60 or 70 or 80. They can be up to 90 carbons in this kind of a soccer ball. And fullerenes are still being researched, and there's still a lot of work being done with fullerenes. Fullerenes are usually found in space, so it was really quite unusual to make them on Earth. Okay, and so it has to be made in vacuum under high pressure. And so fullerenes are a new allotrope of carbon that was discovered 25 years ago. But anyhow, these are 4 allotropes of carbon, and you can see just by looking at this is that they're so different, okay, from each other, which makes carbon even more wonderful to work with. Okay, so let's go over some nomenclature of benzene compounds. And so here is benzene. Let's start with this. Benzene is called, of course, benzene. They're also called arene compounds. And if you look at some of the organic journals, you might see this symbol, and this is Phi-H. Phi stands for the phenyl ring, and then H is the hydrogen, the 6th hydrogen in there. So you can call it any of these things, and you can write benzene like this also, and it's usually commonly written like this in organic journals. You take away one of the hydrogens, or you make it a substituent, and it becomes phenyl. And you've seen this before in Organic 1, where phenyl is used as a substituent. It's also called the aryl group, and then here is a symbol for it in case there is no hydrogen, right? And so this is just the Phi symbol, no hydrogen. So when you start having substituents on benzene, then there will come across 2 names for all benzene compounds as usual, IUPAC and general names. Okay, and you have to know both, otherwise I wouldn't be covering them. So the first one here, this is called chlorobenzene. So just one substituent on the benzene group is called chlorobenzene. And the general name for this one is phenyl chloride. So where you use benzene as a substituent, it's called phenyl chloride, but otherwise the IUPAC name would be chlorobenzene. Similarly, for a bromine substituent, you would have bromobenzene or phenyl bromide. And then you can also have the fluorobenzene and iodobenzene and so on. So I didn't want to write all of those, but it's similar. When you have an alkyl group on the benzene ring, then you can call it methylbenzene. It's very commonly known as toluene rather than methylbenzene. If you go to any lab and ask somebody for methylbenzene, they'll actually have to think twice about this, but toluene, everybody knows what you're talking about. So that's what it means by when we say we have general names. But anyhow, so that's toluene. You can also have other substituents. So for example, if you have an ethyl group over here, that will not be called toluene. Okay, that would be called ethylbenzene. If you have 3 carbons, then you would have propylbenzene, but then you have to specify whether it is N-propyl or isopropyl. When it gets to larger chains, then you have to see whether you want to use the benzene as your base name or you want to use the chain as your base name. If you use the chain as your base name, which is very common, then of course the benzene becomes the phenyl. Okay, and so that's how it goes when you have larger alkyl groups on there. Now, if you have an alkene group on there, then it depends, all right? Because if your alkene chain is long, then you name the alkene chain first and use the benzene ring as a phenyl substituent, okay, to just avoid confusion, all right? Otherwise, if you have just a small one like this is called vinyl benzene, and because this is the vinyl group. It's also called phenylethene because this is the ethene, and here's the phenyl group. Very common name for this is styrene. Okay, and so there are 3 names for just one compound, and you can call it any, and I can give you any, okay, for this compound as well. Although I usually don't give styrene, I will tell you vinyl benzene. Okay, I use that more than styrene. Then here is a benzene with an alcohol group, which is called phenol then. So phen is coming from, of course, the phenyl group, and then ol is coming from the alcohol. This is also called hydroxybenzene. Of course, we know that OH groups are hydroxy groups, and you can also call this phenyl alcohol, all right? And so there are so many names again. Here, this one where you have an ether group, this is the methoxy group, so this is methoxybenzene. It is generally called anisole, and yes, I know you're thinking where is the ani and where is the ol. I have no idea, but anyhow, that's the common name for this compound. And then the last name for this one would be methylphenyl ether, as we learned in ethers. Okay, so you can just name the either side of the oxygen and then name it as ether. So all 3 of them, very common names. Methoxybenzene is the IUPAC. Then we have this compound where you have the NH2 group on it, and NH2 is amino group. Okay, so you can call it aminobenzene. However, aniline is also very common for this. So aniline is the IUPAC as well as the general name for this compound. Okay, and then if you have a nitro group, NO2, which is also very common, common acid commonly found on benzene rings, and this is called nitrobenzene. Okay, and aren't we lucky? This one has only one name. Yep. Continuing on to some other groups that we have attached to benzene, and one is the COC group, and the COC group is known as acid group, and you will encounter this a lot. Okay, so like in acetyl or acetylene, acetic acid. So there is a C double bond O and then C group, and this is the acid group. So this one here, this is a keto group also actually, C double bond O. This is known as acetophenone. Okay, so the acid is coming from this part, and the phen is coming from the benzene ring, and the O is coming from the keto part, all right, for this group. This compound here is called benzaldehyde, and this is when you have the CHO attached to the benzene group. Okay, and so benzaldehyde. This here is benzoic acid, COOH. Okay, so a carboxylic acid attached to benzene is benzoic acid. These groups over here, they're slightly different, and what is different about them is that you have the benzene ring and you have a CH2 attached to it, and then you have a substituent. Okay, so it's a PHCH2 and then whatever. Okay, and so this group is known as benzyl group. So for example, here is benzyl bromide, and the benzyl bromide, the bromine is not directly attached to the benzene group. Okay, it is attached via CH2. So you really have to remember this part because it's so easy to call benzene a benzyl group rather than a phenyl group. Okay, so you really have to differentiate between the two. Here's another example. If you have an OH attached to benzene, not directly, but through CH2, then it is called benzyl alcohol. So again, remember, benzyl has to do with this pH CH2 group, okay? I've given that little over here also so that you will remember that the benzyl group has an additional carbon on there. So easy to forget. Let's look at some of the dye substitutions that we have for benzene rings. And when you have a cyclic compound, just like a straight chain also, you have to give a point of reference. In straight chain, it's the longest chain. In cyclic compounds, you pick one, okay? And so in benzene compounds also, you pick one, all right, whichever it is. If it's a 1-2 relationship, so between X and Y over here, if it's a 1-2 relationship, you can write that as 1-2. Then you can also write that as ortho. If you have a 1-3 relationship, so X and Y, it's separated by one carbon, then you can also call it 1-3, or you can call it meta relationship. And then if it's 1-4, then it would be a para relationship, right? So here is 1, 2, 3, 4. If you take the Y and substituent and you move it once more, then that will be back to a 1-3 relationship, counting from this side. So this is the max that you can have, which is 1-4. Okay, so you have 1-2, 1-3, 1-4, ortho, meta, para. Okay, so here are some examples for it. If you have two groups like chlorine groups and they're both next to each other, they have an ortho relationship or they have a 1-2 relationship. So you can say ortho dichlorobenzene, and this can also be called 1,2 dichlorobenzene, 1,2 coming from relationship, dichloro for two chlorines, okay, and so on. And then here, this is metaperbenzoic acid, and you've seen this one before, metachloroperbenzoic acid. You've seen this before when we talked about epoxides. But anyhow, when you have two groups like this, okay, the first one was easy. When you have two groups where you're not able to decide which one to call the base name, you choose the harder one as your base name. Okay, harder one meaning you don't know what this substituent is, so you use that as your base. Okay, which means that is a peroxybenzoic acid. That is going to be your base, and chlorine is going to be your substituent. All right. You can call it chlorobenzene if you want to, but then what is this? Okay, and so if you don't know that, don't go there. And just take the easiest path, okay, in this case. So this one becomes then a metachloroperoxybenzoic acid. Metachloro for the fact that you have a meta relationship or a 1-3 relationship. So this is 3-chloroperoxybenzoic acid. If you note over here, okay, for this compound, we did not have to give two numbers. We had to give two numbers over here, 1, 2, because both of these compounds were the same. Both of the substituents here were the same. But here, your benzoic acid, your peroxybenzoic acid is your base. So you've already accounted for this group. So which means you don't have to say it anymore. So then you just have to say 3-chloro, okay, and then the base name. So here is another example, and this one is for para. Now you can call this nitrobenzene or you can call this phenol. Okay, so whichever one you want, it's fine. You have to know both. It's easier to call it phenol because phenol is a legitimate compound. Also is nitrobenzene, but it's much better to call this phenol because the OH is directly attached to the benzene, okay, and it does have a name. So then this one becomes para-nitrophenol. So again, you don't have to say hydroxy separately because that is right there in the name, okay, with the phenol. The IUPAC name for this one would be then 4-nitrophenol. Okay, the 4-nitro from the relationship. And again, you don't have to say hydroxy because it's already accounted for in the phenol part. All right. It's kind of redundant to call this 1-hydroxy-4-nitrobenzene. Okay. That is not something that you would do for dye-substituted benzene. It is much better to give it a name if the benzene derivative has a name, okay, like phenol. So don't try to be cute and don't go that way, okay? Just keep it simple. All right. So here are some examples of di and tri-substituted compounds, okay? And so these are some of the common names, okay, that you will find. And some of the common name for, say, this one, where you have the two of the methyl groups over here. Now, this is a meta relationship. Two methyl groups on a benzene, that's called xylene, and the xylene can be orthoxylene, metaxylene or paraxylene. Okay, and so this is ortho, meta, para. There are three possible. So this one is metaxylene. It is also methyl toluene, meta-methyl toluene. How odd is that though? Okay. On the other hand, you can also call it 1,3-dimethylbenzene. So you can have many names for this. Okay, but xylene is the common name. Here is when you have three methyl groups on the benzene ring. This is called mesitylene. You can also just call it 1,3,5-trimethylbenzene. Okay, and that is perfectly acceptable if you do not remember mesitylene. I don't have you remember mesitylene. This one here is orthotoluic acid, which is really weird but it makes sense in a way because the tol is coming from the toluene and the ic acid is coming from the benzoic acid. Okay, and as soon as you say tol, you know that you have a benzene ring because tol is from toluene. Okay, and so that already has a benzene ring in it. So here is orthotoluic acid. You can also call it orthomethyl benzoic acid. All right, that would be perfectly acceptable for this. This is cresol, and the fact that it's saying that this is para, it means that you would have again ortho, meta, para. There are three derivatives possible. Similarly here also, okay, with the orthotoluic acid. So the common name here, this is cresol. So cresol again, you can have three derivatives. This one here is 1,3,5-trinitrobenzene. Okay, and so now you have there is no general name for this. Okay, and so you just simply give it whatever substituents you have, those numbers, and then you call it benzene. Okay, here you do have a possibility of calling it the base as phenol, so you will list it as phenol. Okay, and then since you call this phenol, you have to start the numbering over here. Okay, and then go closest to wherever the substituent is. So here is a substituent. You can go either way. So 2, 3, 4, 5, 6. So 2, 4, 6 trinitro, and then here is the phenol part. Okay, and so that's how you would do it. If there was CH3 over here, this would be trinitrotoluene, which, think about it, trinitrotoluene. Yep, TNT. Okay, that's the short form for it. Anyhow, moving along. Here are some other examples, okay, for nomenclature. So if you have three substituents like this, where do you start? You start closest to the branching. That's all you do, as we learned in the cyclic compounds before. So here's 1, 2, 3, 4, 4 bromo, 1, 2-dimethylbenzene. Very simple, straightforward. This one here, you can give the base name as phenol. Try not to name all the three as substituents, okay, because you do have something with the base name of phenol here, or something that has a base name. So give it phenol and then 2,5-dimethyl, okay, and then this is orthodichloro. We did that already. Parachlorobenzaldehyde. So 1, 2, 3, 4, 4-chlorobenzaldehyde or parachlorobenzaldehyde. So again, we don't know what the substituent is called. We do know, actually, we just haven't done it yet. It's called carbaldehyde, but we haven't done this yet. Okay, so just name this one as your base chain, as in benzaldehyde, and then use chlorine as your substituent. Okay, here is an example of a long chain alkane. And this is where we have to use the benzene ring as a phenyl substituent. Okay, instead of using benzene as a base, you have to use benzene as a substituent. So you find the longest chain, and then you number from the branching, closest to the branching, and the 2 here is phenyl, and then heptane. Okay. This slide you may have seen before in aromaticity, and these are some of the compounds that I do expect you to know. Okay, so I put them again here so that will be a review also, and you will know that you need to know these. Okay, so pyrrole, for example, you need to know this. Furan you need to know, and thiophene. These are all aromatic compounds, and these are heterocyclic compounds, so you do have to know them, and eventually you'll be learning more of these, okay, in your biochemistry. Regarding the fused ring hydrocarbons, these are also all organic, these are also all aromatic compounds. The ones that I really need you to know is naphthalene, okay, from here, but I've given you the other names also just in case for your reference. But Naphthalene is the one that you need to know because you will encounter this one. Anthracene, if I give you, I'll give you the structure for it, okay, but not naphthalene. Naphthalene is a very common substance, and so you should know. So the keywords and the concepts for nomenclature is, of course, know all the naming, know all the general names, know the ortho, meta, para for the di and tri substitutions, and make sure you know all your base names properly.